Hey, good morning, everybody, and or afternoon, depending on when you're watching this, or early evening, late evening, however it may work. But today we're going to be starting section 4.3. Section 4.3, where we're going to connect what f prime, and f double prime, and how the relationship between those graphs and those functions is really quite remarkable. And there's some amazing things that we can find from them. And this is going to be a while. This is going to be something that's going to take some time to soak in, and you got to really be paying attention to this stuff. So let's take a look. So when you take a look at this graph here, we notice it's a continuous graph because I can, take my whole graph the whole time, and they talk about what's happening to my graph here. And this is really where everything is being connected. At least for f and f prime. Okay. And so one of the things that I notice about this is we always talked about how when f prime is positive, that f of x is increasing. Well, that can be seen here, right? F prime is positive because I'm increasing. My slope is positive. My slope is negative. Okay? And so what we're going to do is we're going to try and find this algebraically. And that's what we're really going to be doing as far as connecting things. Okay? And one of the things that I notice here is if I look at where all my maxes and minimums are at, look at this. Here's a local max right here. And notice what happens to f prime. F prime switches from being positive to negative. F prime switches from positive to negative means that f has a local max, because f switches from increasing to decreasing. And also wouldn't care when it's a local minimum. Okay? I come here and I take a look. Hey, it switches, the f prime switches from from negative to positive. Here's negative, here's positive. And it switches from decreasing, okay? My f switches from decreasing to increasing. Again, just these little things are noticing as you need to notice, because that will help you algebraically find out where your maxes and minimums are at. So here we go. Take a look here. So what we're going to implement is what's called the first derivative test. One of the things that in order to do the first derivative test, I need to go out and find critical points. Okay? Recall that critical points are any points where f prime of x is equal to 0 or f prime of x does not exist. Alright? So those are the three key things. Then what it says here is that if f prime changes sign from positive to negative at that critical point C, then and that means that f prime is greater than 0, and then switches to f prime being less than 0, then f has a local maximum value. And here's a demonstration of that. Okay, and I kind of talked about that earlier. And at that same critical point, if f prime changes sign from negative to positive, okay, again that means that f prime is less than 0, and then switches to f prime being greater than 0, then f of x has a local minimum value. Look at this, f prime is less than 0, f prime is greater than 0. That means f of x goes from decreasing to increasing. Okay. Notice it also happens here when f prime does not exist, right? Undefined. Okay, so then I come here and I take a look. Okay, what happens now if f prime does not change sign? Well, if f prime does not change sign, in other words, it goes from f goes from increasing to increasing, or f prime is positive to positive, okay, then there is no local extreme value. There's no local minimum or local maximum. And then these are very specific ones to endpoints if we're dealing with a closed function and what you need to show to prove that you have a local maximum and local minimum. Okay? And again, that's really what the heart of calculus is doing, is that you guys have dealt with local maximums and local minimums before. But now what we're going to be doing is we're stepping it up, and we're going to show, we're going to justify, we're going to prove that I have a local max, a local min at these different places. Now the ones for the left endpoint and the right endpoint, you need to know, but they're kind of intuitive in that if I'm stuck here and this is my endpoint A and here's my here, and if I go just a little bit to the right of it, and I am seeing that f prime is less than 0, that means that I am decreasing, that my function is decreasing, then what I'm able to see is that I have a local max for my function. Vice versa, if my left endpoint is here and my derivative is greater than 0 just to the right of it, and that means that my function is increasing, then I have a local minimum at that point. And the opposite could be said for right endpoints. Okay? Kind of intuitive, but we'll get there. So let's see how this actually works. So actually on this slide, don't worry about B. Okay? You have a separate slide for B. So we're going to take a look at A. So I'm looking at A. So use the first derivative test to find the local extreme values. Identify any absolute extrema. So first derivative test means that I need to go take the first derivative. So the first derivative here, so in other words, f prime of x is going to be equal to 3x minus a 12. And since I'm going to be finding, I want to set this equal to 0 or does not exist, I'm already thinking that in my head. I would probably want to factor some things out to make this a little bit easier for myself. Oops, 3 pi x squared. Okay, and so when I do that, I can go say that f prime of x is equal to 3 times an x squared minus a 4, which means that I can say that f prime of x, because I want to factor even more, and say this is x plus a 2, x minus a 2. Alright, so my next step after I find this is I want to set it equal to 0 or where it does not exist. And hopefully at this point you can see that this function that we have here, this derivative, okay, exists everywhere. I can put any x I want to in there, it's going to be fine. So the only thing I'm concerned about is finding out when does f prime of x equal 0. And if you were paying attention in Algebra 2 and Pre-Cal, and you already say there, well, that means that at that point x equals 2 and x equals negative 2 are my two possible critical points, and I have to look at for maximums and minimums. Alright, so once I get that, what do I do? Well, what I like to do is I set up a little graph, a little table and graph, and I take a look here, what's negative 2 and 2, and I want to see what's happening to the value of my derivative at those points and in between. So I look over here, I'm at negative 2 on my number line, and I go on any number less than negative 2. If I choose any number less than negative 2, I want to go big because I can go all the way up to infinity. So I'll put like negative 1,000. And what I'm going to do is I'm going to plug in negative 1,000 into f prime. And I'm going to find out what sign is it going to be. Is it going to be positive or am I going to be negative? So when I stick negative 1,000, I have a positive 3 times a negative times another negative, because a negative 1,000 will make both of these negative. So a positive times a negative, oh, f prime will be positive. Well, if that means f prime is positive, what does that mean for f of x? Well, f prime is positive, that means my slope is positive for f of x, which means I'm increasing for f of x. So I'm going to make a little arrow, increasing. And then I go ahead and let's stick a good number in for negative 2 to 2. Well, 0's in there, might as well make it 0. So when I plug in 0 into f prime, I now have positive 3 times a positive 2 times a negative 2. So positive times negative means f prime is negative. And what does that mean for my function? That means in that interval, my function is decreasing. And then I'm going to go ahead and do a little bit more and say, okay, what about past 2? So again, positive 1,000. So I put a positive 1,000 in here, and I get positive. So it's all positive, which means my function is increasing again. And hopefully by this little graph, you're able to see what's happening at 2 and negative 2. Here at negative 2, my function goes from increasing to decreasing. So I have some type of local max here. And over here at positive 2, my function goes from decreasing to increasing, which means that here I have a local min. Well, that's great and dandy. You proved it to yourself that you have a local max and a local min, but you have not proven it to somebody reading this question. In order to prove it, you need to write out what you're saying here. Okay? So here's how we write it, and I'm going to write it in the least amount of words as possible to make life easy for you. Okay? But you do need to write it this way. You will say, since f prime of x changes from positive to negative at x equals -2, comma, f of x has a local max at x equals -2. And then I would go ahead and similarly say the same thing for the local minimum. I would say, well, since f prime of x changes from negative to positive at x equals 2, f of x has a local minimum at x equals 2. And then the question comes along and was like, well, I'm also supposed to identify if there's any absolute extrema. And so in theory you would have done this beforehand, but what you should have noticed while you're creating your graph here, right, while you're creating your chart, you should have seen that your sketch of your graph would be, well, hey, I'm just going to do a little sketch of it, right? Here I am before -2, all right? So here's -2, here's +2, and I have some type of local minimum over here, and I have some type of local max at +2, -2. Well, what's happening? I'm coming in and I'm increasing the whole time I'm getting up there, okay? And then I'm decreasing to get down to the -2, and then I'm increasing again. And so I'm creating this little sketch of f of x. And what you should notice is, hey, this graph shoots off to the big positive. And this graph over here is shooting out the big negative, so there are no absolute maxes or mins. All right? And so you got to be able to picture that and see that. Okay? Cool. In fact, here's the actual graph of what we just had. And there it is. And it looks about what we drew. Okay? All right, let's do the next one. Boom. Okay, so it says here, for each of the following functions, use the first derivative test. So it's the exact same thing, except I'm going to do it for part B, not part A. So let's go ahead and do the same thing. If you notice what I have here is I have a function and a function, which means I'm doing product rule. So g of x is leave the first, g prime of x, excuse me, is going to leave the first one alone. So that's going to be x squared minus 3. And take the derivative of the second. Derivative second of e to the x is e to the x plus, take the derivative of the first, which will just be 2x, times, leave the second alone, e to the x. Again, since I'm going to be setting g prime equal to 0, I want to go ahead and factor things out. I notice I have an e to the x on both of them, so I'm going to factor that out first. Factor out e to the x, I get an x squared minus a 3 plus a 2x. And then I notice, well, hey, I can go ahead and rearrange the inside here, and I can see that g prime of x is equal to e to the x times x squared plus a 2x minus a 3. And then I say, well, hey, I can go ahead and factor this inside piece even further. And I can say, well, now g prime of x is equal to e to the x times, well, that's going to be x plus 3, x minus 1. And there I go. There it is, completely factored. Woo! I have to go through the same set, right? I want to find out when is g prime of x equal to 0, so I got to set this equal to 0. And I have to find out, well, when is it equal to 0? And you should see easily that x equals -3 and x equals 1 are critical points. But what happens here with e to the x? And this is where you have to remember that e to the function x will never, ever, ever be negative. Why? Because you need to know what the function looks like. The function e to the x, okay, the function e to the x, remember, let's draw that better. Okay, looks something like that. It'll never, ever, ever be negative. Okay, so it will never cross the 0, and it's never 0. So those are my only two critical points. I go ahead and I set my critical point test again, right? Little test. I sit here, well, I'm going to be at -3. I'm going to be here at 1. I'm going to go ahead and this is g prime of x. Always label it for yourself. And up here is going to be g of x. And so then I start thinking about or going, all right, so I'm going to again choose that -10,000, -1,000 for over here. Put a -1,000 here. Again, it'll never be negative, so it's always going to be positive. -10,000 is negative, negative. So put that in there as negatives. Positive times negative is a positive, which means g of x is increasing. Between -3 and 1, I'm going to choose 0. When I put 0 in here, it's going to be 1, so it's positive. Positive, negative. So positive times negative is negative, which means I'm decreasing. And then for g prime, and I put in 1,000 into g prime. Okay, I go ahead and the 1,000 is going to be positive, 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 which means I'm increasing. And again, you find out, you take a look while I'm switching my g of x is going from increasing to decreasing, which means that right here at my critical point, I again have a local max. And this one over here, I go g of x is going from decreasing to increasing, so I have a local min. And I look at it again, and I say, do I have any absolutes? Well, again, I have the same type of graph that's doing this, and I'm not going to have anything because it's going to get lower on the one side and get higher on the other side, so none of them are absolutes. Okay, so again, I go to the same type of phrase. Okay, and it's going to be since g prime of x equal changes from positive to negative at x equals -3, comma, g of x has a local max at x equals -3. And repeat for the other one. Since g prime of x changes from negative to positive at x equals 1, g of x has a local min at x equals 1. And there you go. Now, it may seem like a lot, but you do need to write this stuff. You do need to have it written this way because this is how the AP exam is going to judge you. Okay, it won't judge you on all of this. You'll get some points for doing all this algebraic work and getting a setting equal to 0, but your justification piece comes from here, not from here. So what I'm going to do is I'm going to go ahead and end part 1 here, okay, and we'll start part 2 next, okay.